Hello. In today's lesson, lesson 2.5 on page 63 of your fourth grade Go Math book, we're talking about multiplying using the distributive property. And I find that this property is one of the most useful properties in math. It helps make problems a lot easier to solve because we're allowed to break numbers into smaller parts to multiply. So like in our example, rather than saying 6 times 13, I can think of it as multiplying the sum of 5 and 8. So 6 times 5 plus 6 times 8 may be easier to do than 6 times 13. Okay, 13 is not that difficult of a problem to multiply, but you can apply this to much larger values, and it can help us come up with our products. So in this lesson, you'll want to have grid paper, extra grid paper for some of our practice on pages 64 and 65. And you may also get a piece of lined paper so we can do some calculations as well. All right, so the grid paper you can find in materials of the Classroom Google of our classroom. Go ahead and print that out if you need to. All right, so let's get started. You also need color pencils, markers, or pens, at least 2, and then your pencil or writing utensil. Okay, so you can use the distributive property to break apart numbers to make them easier to multiply. The distributive property states that multiplying a sum by a number is the same as multiplying each addend by the number and then adding the products. Distributive property states that multiplying a sum by a number is the same as multiplying each addend by the number and then adding the products. So part A says outline a rectangle on the grid to model 6 times 13. All right, so 6 times 13. So I'm going to go down 6. 1, 2, 3, 4, 5, 6. I'm going to go across 13. 6, 7, 8, 9, 10, 11, 12, 13. Okay, so right now, our model shows 6 times 13. Okay? 6 rows of 13. Now, part B, think of 13 as 5 plus 8. And so you see here, we took the 13 and split it into 6 rows of 5 and 6 rows of 8. And label and shade the smaller rectangles, use 2 different colors. So count across 5. 1, 2, 3. 1, 2, 3, 4, 5. Go down because it's 6 rows of 5. And shade that in. And then we have 6 rows of 8. So what did we do? We took the 13 and broke it into 5 plus 8. Okay, so the whole thing, remember, is 13. This little section here would be a 6 times 5. This part here would be 6 times 8. So we've taken this long, big rectangle and split it into 2 rectangles. So now we're going to use the distributive property, and we're going to find the product of each of the smaller rectangles. And then we're going to find the sum of the products. So we know that one of the rectangles is a 6 by 5. We now know another one is 6 by 8. So 6 times 5 is 30, and 6 times 8 would be 30. Sorry. 6 times 5 is 30. So add 15, 18 more. So 3 more 6s, 18 more, and we get 48. So 6 times 8 is 48. Now, these are our sums of our two smaller problems, and now we need to add those together to find the product. So 30 and 48, 8 plus nothing is 8. 4 tens plus 3 tens is 7. So 6 times 13 is 78. Now we're going to model 6 times 13 again, but this time we're going to think of 13 as a different sum. So break apart the model to show 6 times the two numbers that we're using to add, the two add-ins that we're using to find 13. So I'm going to keep the 6. 1, 2, 3, 4, 5, 6. So go down 6. This time I think I'm going to break it into 10 plus 3. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So again, right now that's 6 by 13. We want to make it into two smaller rectangles. And I'm going to use a 6 by 10 and a 6 by 3. Now you can choose any two numbers that add up to 13. You could use 9 and 4. You could use 7 and 6. You could use 11 and 2. But we're trying to find something that's easy for us to do mentally. And then I'm going to shade my 6 by 3. So this section here is 6 by 10. This smaller section is 6 by 3. So my distributive property, I broke 13 into 6 times 10 plus 3. So we're multiplying the sum of 10 and 3 by 6. So we're going to go 6 times 10 plus 6 times 3. 6 times 10, 60. And 6 times 3 is 18. We're now going to add the sum of our two smaller rectangles. 60 plus 18 gives me a sum of 78. So 6 times 13 again is 78. So you'll see that it doesn't really matter how I break up 13. Okay. All right. 64. So explain how we found the total number of squares in each model in steps B and C. So what did we do? How did we find the sum? Well, we divided the first model. Okay, so how did you divide the first model? Well, we did a 6 times 5 rectangle and a 6 times 8 rectangle and added. I divided in part C. Let's change the writing of that. In part C, I divided the rectangle into a 6 times 10 and a 6 times 3 rectangle and added. Okay, so regardless of what you broke the 13 into, it's the same process. You're going to have two smaller rectangles and you're going to add them together. All right, so 2, compare the sums of the products in B and C with those of your classmates. What can you conclude? Well, since we're doing this virtually, we really can't compare, but we can say that the sums of the products will be the same. Okay, I did 10 and 3. Somebody else might have done 7 and 6. But regardless, we have to have the same sum for the product because 6 times 13 is 78. All right, number 3. So to find 7 times 23, do you think it is easier to break apart the factor 23 as 20 plus 3 or 15 plus 8? Well, based on our last lesson, I'm going to say it is easier to break apart factor 23. 7 times 20 can be done mentally. And so can 7 times 3. Okay? I just think it's probably easier to do that than to break it into 15 times 8. Okay, some students may not be able to do 7 times 15 mentally in their heads, so it's a more challenging problem. But we know that 7 times 20 is just 7 times 2 gives us 14, and we can place the 0 from the 2 tens. All right, so that's one way. Okay, using a model, using grid paper, breaking it into smaller rectangles. Another way we can do that is to use base 10 blocks. Okay, and so we see here we have the same problem, 6 times 13, and I see 6 rows of 110 and 3 ones. So 13, 13, 13, 13, 13, 13. So 6 rows of 13 would be 78. 6 rows of 10 is 60. 6 rows of 3 is 18. 60 and 18 is 78. So now we're going to see that. So 6 times 110, 6 rows of 110, is the same as saying 6 times 10, which is 60. 6 times 3 ones is the same as saying 6 times 3, which is 18. And then we'd add those smaller sums. We'd add the result of our 10s and our 1s, the products of our 10s and our 1s. Step 2, this part here, shows what we call partial products. Partial products means it's a part of the product that has to be solved. So in this case, we have 2 partial sums, 2 sums that we add to get the product. Okay, so model on the grid paper, record your product. 3 times 13. So we have 3 rows, and we have 13 in each row. So we have 3 times 13, and we want to make that into 2 smaller rectangles. And again, I like the 3 times 10. So I'm going to do 3 times 10 and 3 times 3. So 3 times 10 and 3 times 3. What did we do? We split the 13 into the sum of 10 and 3. We're going to multiply 3 times 10. 3 times 10 equals 30, plus the second rectangle of 3 times 3, which is 9, and then we'll add 30 plus 9. So 3 times 13 is 39. 5 times 14. So I'm going to go down 5 rows. 1, 2, 3, 4, 5. I'm going to go across 14. So the whole rectangle is 5 times 14. We're going to break this into smaller rectangles. I'm going to use 5 times 10. Plus 5 times 4. So I split the 14 into 10 plus 4. So my two smaller rectangles will be 5 times 10 plus 5 times 4. 5 times 10 is 50, plus 5 times 4, which is 20. And we get an answer of 70. We get a product of 70. So we can also find products using base 10 blocks. So we see here we have 6 rows of 110 and 4 ones. So we have 6 times 10 plus 6 times 4. 6 times 10 is 60, plus 6 times 4 is 24. 60 and 24 is 84. In this problem, we have 5 rows of 18. So we have 5 rows of 110 and 8 ones. So we're going to have 5 times 10, that's this section here, plus 5 times 8. 5 times 10 is 50. 5 times 8 is 40. 50 and 40 is 90. 4 times 16, we have 4 rows of 110 and 6 ones. So the 10s would be 4 times 10, and the 1s would be 4 times 6. So 4 times 10 is 40, plus 4 times 6 is 24. Add those together, we get a product of 64. Okay, number 6, use grid paper or base 10 blocks. So 7 times 12. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so 1, 2, 3, 4, 5, 6, 7 by 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 7 by 12. We're going to break that into 2 smaller rectangles. So I have my 7 by 12 grid. And I want to break that into, I'm going to do 7 times 10 and 7 times 2. Okay, let's just confirm that that makes sense. 10 plus 2 is 12, so that's right. And we know that the width of this rectangle stays the same at 7. So we're going to have 7 times 10, 70, plus 7 times 2, 14. So 7 times 12 equals 84. Okay, number 5. So if we're going to use, let's use base 10 blocks for this one. So number 7. So we have 5 times 16. So 1, 2, 3, 4, 5. I have 5 rows of 16. So we have 5 rows of 110 6 ones. So that's 16, 5 rows of 16. So the tens would be 5 times 10 plus 5 times 6. 5 rows of 6, 5 rows of 10. 10 plus 6 is 16. So all we did was split up the 16 into 10 plus 6. All right, 5 times 10 is 50, and 5 times 6 is 30. So 5 times 16 is 80. And number 8. So let's use grid paper for number 9. And we're going to have a 9 by 13. So 9 down, 13 across. And then I'm going to break up the 13 into 10 plus 3. So I'm going to have 9 times 10, and I'll have 9 times 3. So 9 times 10 plus 9 times 3. So 9 times 10 is 90. 9 times 7 is 27. 7 ones plus no ones is 7 ones. 9 tens plus 2 tens is 11 tens. So 117. Number 9. So explain how modeling partial products can be used to find the products of greater numbers. Okay, so remember, the idea of this distributive product was not necessarily for these smaller numbers that we're practicing, but so that we can use the same concept for much larger numbers. And so using base 10 blocks, you can skip count by tens. Or multiply by multiples of 10. Okay, so what they're saying is like in this one, we can go 10, 20, 30, 40, 50, 60, or I can say 6 times 10. Okay, so that would be um, how we could use the base 10 blocks. Okay, and then we would multiply basic facts to find the number of ones. Okay, so in our partial product of this one, our basic fact was 6 times 4, so we just multiplied 6 times 4, we said 24. In this one, I said 5 times 8, that's just 40. So those are basic math facts. Then you're going to add the two numbers. Add the numbers to get the product. Add the number of tens and ones to get the product. So all we did here was write out the explanation for what we've been doing with the base 10 blocks. We multiplied to find the number of base of 10 blocks we have, and then we added this product of the ones. So number 10, use the distributive property to model the product on the grid. Record the product. So we have 4 rows down. Okay, we have a 4 by 14. So the whole rectangle is 4 by 14, but we can break that into much smaller problem. Okay, and I'm going to use again 4 times 10. And I'll use 4 times 4 for the second rectangle. So I broke up the 14 into 10 plus 4. I'm still multiplying. I still have the same number of rows. So we have a 4 times 10, and we have 4 times 4. And we're going to add those together. So 4 times 10, 4 is 16, and 4 times 10 is 40. So together we get 56. All right, page 66. Number 11. So Kyle went to a fruit market. The market sells a variety of fruits and vegetables. The picture at the right shows a display of oranges. All right. Write a problem that can be solved using the picture. Okay, well, I see 6 rows of oranges, 6 rows of 12 oranges, and I see 6 rows of 2 that are empty. So let's see. A display can hold 8 rows of 12 oranges. If 2 rows of 12 are empty, how many oranges are there? Or how many oranges are in the display? So that's just one way. I mean, there's no right or wrong answer. You could just say that there's 6 rows of 12 oranges. How many oranges are in the display? Or you could say a display has 8 rows of, can hold 8 rows of 12. How many, what is the most number of oranges that the display can hold? So there's no right or wrong way of writing this problem. You just you write a problem that you can solve. Okay, and so we have 8 times 12. Now, we're going to break that into 2 smaller problems. Okay, I'm going to go ahead and use base 10 blocks. So 3, 4, 5, 6, 7, 8. I have 8 rows of 110s and 2 ones. Okay, so we have 8 times 10. There are 8 tens plus 8 rows of 2. So how much do we have? We have 8 times 10 is 80. plus 8 times 2 is 16. So we have 96 oranges could be displayed. Okay. There's 2 rows of 12 that are empty. So that would be 2 times 10 plus 2 times 2. 2 times 10 is 20. 2 times 2 is 4. So we need to subtract 24. There are 72 oranges in the display. Describe how you could change the problem by changing the number of rows of oranges and the number of empty spaces in the picture. Let's see. One display can hold 9 rows. So they told us to change the number of rows of oranges. 9 rows of oranges. 9 rows of 12 oranges. Sorry about that. We have to indicate how many oranges are going to be in each row. So 9 rows of 12 oranges. If 5 rows in the display are empty, how many oranges are in the display? Okay. So if it was filled, it would be 9 times 12. I'm going to say filled display. If I have a filled display, it would be 9 times 12. And I'm not sure what that is. So I'm going to break this apart into 9 times 10 plus 9 times 2. And what does that equal? 9 times 10 is 90. 9 times 2 is 18. We're going to add those together. We get 8 ones, and we get 10 tens. So 108 if it was filled. But we have 5 rows of 12 are empty. So we have 5 times 12 is empty. So I'm going to break that into 5 times 10 plus 5 times 2. 5 times 10 is 50 plus 5 times 2 is 10. So we have 60 that are missing. So total oranges in display would be the 108 that it could hold. It can hold 108 oranges. 60 are missing. So how many oranges do I actually have in my display? 8 take away 0 ones is 8 ones. I can't take 6 tens from no tens. So I'll regroup from the 100. I'll change the 100 to 0 hundreds and 10 tens. 10 take away 6 tens is 4 tens. So there's 48 oranges in my display. Now your numbers might be different than mine, depending on what you said, with how many total rows you had of oranges and how many empty rows. So all of page 66, there's really no right, only one right answer. It really is just having to practice the concept of distributive property. Okay, so that's it for today for lesson 2.5. And until our next lesson, may the numbers always be in your favor.